So in organic chemistry, the first part is the understanding of naming of compounds, that is nomenclature. So when I started with the naming of the compounds, I had given a simple rule, a Brahmastra you can say, to name any given organic compound, and it is made up of 5 parts. The 5 parts are written in the order 2 degree prefix with 1 degree prefix, the word root, 1 degree suffix and 2 degree suffix. Each and everything has the meaning and it has to be followed in the same order. 2 degree prefix indicates the name of all the substituents which are not included in the parent chain. So it indicates the name of all the substituent. 1 degree prefix indicates the cyclic or acyclic nature of the molecule. So if it is cyclic, you have to include the prefix cyclo, else you have to ignore this. If it's a cyclic ring, include cyclo, else ignore it. Word root, this indicates the carbon skeleton, including the main functional group, or instead of the functional group we can have a multiple bond. MB indicates the multiple bonds if it is present, because if it's a normal hydrocarbon of an alkane, then it would not have a functional group or a multiple bond. So there is a condition of if present. So the carbon main skeleton including the functional group of the or the multiple bond indicates the word root. That word root is basically the number of carbons. So if it is 5, it is pent, 6 it would be hex, 7 it will be hep, and so on. उसके बाद the 1 degree suffix indicates the presence of the single, double or a triple bond. If it is a single bond, the word root has to be suffixed with AN. If it is a double bond, EN. If it is a triple bond, YN. And then the main suffix, which is related to the main or the functional group of the highest priority. Correct? So this is how you have to follow the order of naming any given organic compound, literally any given organic compound. Okay? So in the order, substituents with the cyclic or acyclic nature of the ring, followed by the main skeleton, then the single, double, triple presence, followed by the 2 degree suffix of the main or the highest priority functional group. Okay? Next, if we talk about the functional group ka positioning, then the numbering is generally with respect to the higher priority functional group. If the functional group is not present, then we move to the presence of the double bond, that is multiple bond. If the multiple bonds are not present, then we look at the substituents. So basically the lowest numbering is with respect to first looking at the functional group. If not present, then the multiple bond and then the substituent. So this is the minimum position order. Then we have the priority. The priority order is to be remembered. मैं एक सिंपल सा रूल बताता हूँ. जैसे मैंने आपको दिया था ऑर्डर, वही फॉर्म में याद रखना है. You have to remember the rows of the different functional groups in the same order what I am discussing. Meaning, starting with the highest priority, it goes to carboxylic acid, followed by sulfonic acid. Acid is a functional isomer of ester. So the first row includes acid, sulfonic acid, ester. उसके बाद the second row can be remembered as can. Can refers to acyl chloride, C for chloride, then amide, that is CONH2, and N refers to nitride, and nitride is nothing but cyanide. CAN, acyl chloride, amide and cyanide. Followed by next is AK, that is aldehyde ketone. Aldehyde ketone. उसके बाद we have hydroxyl, that is OH, and the amine, OH and NH2. Then we have a double bond followed by a triple bond. And the least priority functional group, which are basically considered as the substituents, and they are halo, nitro, alkoxy and alkyl. They are the least priority functional groups, basically not functional groups, they are merely considered as the substituents. Clear? So this is something which is to be remembered. Now let's take an example to understand this. So I've given the example over there. Let's take a cyclic ring with a ketone functional group, a double bond, halo and methyl. So if we look at this compound, सबसे पहले to name any compound, identify the total functional groups present, and they are three. It's ketone, a double bond and halo. Once you identify the number of functional groups, look at the priority, and the priority goes to ketone, that is C double bond O. So the word root will be identified by including the ketone, and if you include the ketone in the cyclic ring, it has to be all the carbon atoms included, but the numbering will start from ketone. Now you can move in clockwise or anti-clockwise. Yes, you have to move in the anti-clockwise, because after ketone you have a alkene double bond which should get the lowest priority. So you can't move in the clockwise direction, you have to go in the anti-clockwise direction. So numbering will be done starting from ketone, which is respect to the functional group, then in the anti-clockwise 2, 3, 4, 5 and 6. Now the substituents which are not included should be named as the 2 degree prefix. So we have chloro and methyl. If you have more than one substituent, arrange them in alphabetical order. So in the order what we will have is chloro and methyl, hence the 2 degree prefix will be 6 chloro, 6 methyl. So look at the order I am following. I have included the 2 degree prefix. Then there is a cyclic ring? Yes, so you have to prefix cyclo. The word root is with respect to the final number, which is hex. Then is there a single, double or triple? There is a double, so it is ene. And the main functional group is ketone, which is one. Also ene and one ka position needs to be added. So ene is between 2, 3, so it's 2. One is on 1, so it is 1 one. 6 chloro, 6 methyl, hex 2 cyclo, hex 2 ene, 1 one. Clear? So I have just tried to take this example because it includes all the 5 things together. Again, from the name, if I show you 6 chloro, 6 methyl indicates the name of the substituent, a 2 degree prefix. Then cyclo indicates the name of the primary prefix. Hex refers to the word root. In refers to the primary prefix. On refers to the secondary prefix, suffix. Sorry. Clear? This is how the nomenclature is to be done. We can have spiro compounds, which are also called spiroalkanes. Spiroalkanes are those organic compounds which is formed by the fusion of 2 cyclic rings joined by 1 carbon common. Fusion of 2 cyclic rings joined by 1 carbon, which is common. The simplest example of that is we have a cyclopropane joined with another cyclopropane with a common carbon. This type of compounds are called spiroalkanes or spirocyclic compounds बोलते हैं. ठीक है? Spiro compounds are named by writing the prefix spiro, then a square bracket with 2 numbers separated by a dot, and then the name of the alkane referring to the total number of carbons. This is the nomenclature. Spiro, a square bracket with 2 numbers separated by a dot, and then the name of the alkane. This 2 numbers indicates the number of the carbon of the cyclic ring excluding the spiro center. So spiro center is basically the common carbon. Usko exclude karke whatever number of carbon of the ring you see, you have to write in this square bracket. And also the spiro ka numbering is with respect to the smallest ring first. If the rings are of equal size, doesn't matter, but if the rings are of unequal size, the smallest ring always has to be considered first. तो 2 रूल हमेशा याद रखना. स्पाइरो के लिए स्मॉलेस्ट रिंग फर्स्ट आता है, एंड सेकेंड इज वेरी इंपॉर्टेंट, द नंबरिंग इज टू बी डन from the carbon adjacent to spirocenter, adjacent to spirocenter. एक बार फिर से smallest string first consider करना है and the numbering is to be done starting from the carbon adjacent to the spirocenter. So let's start. Firstly, the rings are of equal size, so first rule doesn't apply. Secondly, the numbering should be done adjacent to spirocenter. If this is a spirocenter, this carbon will be numbered 1. It starts from the carbon adjacent to spirocenter. Now how do you number the other carbon? So in the first ring, I will number 1, 2. Then I'll come to the spirocenter and I'll complete the other ring. This is the numbering. Starts from the carbon adjacent to spirocenter, then complete the first ring, come to spirocenter, continue the second ring. Start with the smallest ring first. Now how to name this compound? Spiro is the prefix which is always common, followed by the square bracket, 2 numbers indicating the ring ka size, excluding the spirocenter. So it is 2.2. And the parent of 5 carbon would be named as pentane. Hence we have spiro 2,2-pentane. Is that clear? और एग्जाम्पल ले लेते हैं. Let's say we have this. So everyone, spiroalkane में सबसे पहले you have to start the numbering adjacent to the spirocenter. So it will be either this or this carbon. But then you have to take the smallest ring first, irrespective of the functional group. Irrespective of the functional group. So I will start with the carbon adjacent to the spirocenter. So this is 1. Now here I can move in any direction because there is no functional group. All are same carbon. So it's 2, 3. Come to the spirocenter and now complete the second ring. But the second ring has a ketone, so it has to have a lower number. So it will be 5, 6, 7, 8 and 9. This is how you complete the numbers. Now to name the compound, first you will write the substituent ka name if any present. So we have a methyl on the 9th carbon. So I will write 9-methyl. Followed by the prefix pyro. A square bracket including 2 numbers separated by a dot. So it will be 1, 2, 3 of the smaller ring. So smaller ring first, यानी 3 यहाँ आएगा. उसके बाद 1, 2, 3, 4, 5 carbon of the other ring, that is 5. Then the parent is off. Parent is off. 9 carbon. So we have nonane. And ketone के लिए E will be dropped and replaced by the word one at the position of 6. So it's nonane 6-one. Correct? What is important is the numbering part. If that is done, I think the things are simple. Rest of all the things remains the same. Only that spiro as a prefix is something which is different. बाकी जो रूल हमने 2 डिग्री प्रीफिक्स वाले में किया है, that same thing applies here also. So the name to this compound would be 1-amino 2,7,7 trimethyl. Then we have the prefix pyro with the number of carbons 2 and 5. The parent of the numbers 7, 8, so it's octane, and then 4-one. If it was having a double bond somewhere here, then it would be named as
octane 4 or
oct. सिर्फ यहाँ पे आता oct 7-ene, rest remains the same. Clear? So that's how the spiro compounds are named. Now to remember it in a simpler way, spiro S, say you can remember smallest ring first. Spiro S, remember smaller ring first, and then the numbering has to be from the carbon adjacent to the spirocenter. These two things are the only part which is important to be followed to name a spiro compound. Now next, spiroalkanes के अलावा we have bicycloalkanes. Now bicyclo are those compounds in which two cyclic rings are fused together but with two carbon common. So if you look at this and this carbon, it separates two cyclic rings. 1 2 3 4 1 2 3 4 5 6 7 ये एक रिंग, 1 2 3 4 5 दूसरा रिंग. So bicyclo and spiro में डिफरेंस क्या है? Here one carbon common, two carbon common. ठीक है. Now bicyclo में दो चीज वैसे ही याद रखना है. B से याद रखो. Now bigger ring first. It's a mere coincidence to actually remember it. Spiro S, smaller ring first. Bicyclo B, bigger ring first. With the bigger ring, also remember that here the numbering starts from the bridge carbon. From the bridge carbon. Now here it was adjacent to the spiro center, but bicyclo में this carbon which is joining the two ring are called bridge carbon. Numbering will start from the bridge carbon. Now which end, that will be decided with respect to the substituents or the functional groups which are present. I can either give a number 1 here or a number 1 here. Correct. Now if I start with 1 over here, the bigger ring is to be considered first. Now this is obviously the bigger ring, this is the smaller ring. So I can move either in this clockwise or in this clockwise. Now here the methyl is a substituent which gets a number 2 if I start from this end, or from here I will get ethyl on the second carbon if I start from this end. Now which is the correct numbering? E will come first in the alphabetical order. So the correct numbering is with respect to this end where the ethyl gets the lower possible number. Okay? Now if there was a functional group here and a substituent here, it would have been started from that end. Clear? So it will be started from this end, that is number 1. So दो ही चीज important है, bigger ring first consider करना है and numbering starts from the bridge carbon. ठीक है, पहले numbering कर लेते हैं, फिर I'll tell you the order in which it's to be written. So 1 के बाद this will be 2, 3, 4, 5, 6, 7, 8 and then the bridge के बीच में अगर कोई कार्बन है तो उसको last number देना है. The bridge can have a carbon or it may not have a carbon. If the bridge was like this, direct connecting 1 and 6, there would be no carbon in between these two carbons. But here there is a bridge containing 1 carbon. ठीक है? अब यहाँ पर नेम कैसे करना है? Bicyclo का general way of naming is write the prefix bicyclo similar to spiro, a square bracket now with 3 numbers. Let's say the 3 numbers are x, y, z, and this should be in the decreasing order. Decreasing order, and then the name of the alkane. Decreasing order means the bigger ring का carbon will come first. That's what the rule is followed. उसके बाद the smaller ring, and then z refers to the number of the carbon in the bridge. Bigger ring, smaller ring and bridge के बीच में अगर कोई carbon है तो उसका number of carbon is to be written here. Correct? Now let's do the nomenclature for this given compound. So सबसे पहले we will write the substituents. How many substituents do we have? It's 2 and they are 2 ethyl, 5 methyl. Substituents done? Now start with the bicyclo. अब ये 3 नंबर कैसे करने हैं? From the bridge carbon, the number of carbon here are 4, again excluding the bridge carbon, जो हमने spiro में भी किया था. तो 4 for the bigger ring, 2 for the smaller ring, and 1 for the bridge carbon. It's 4 for the bigger ring, 2 for the smaller ring, 1 for the bridge carbon. So the numbers are 4, 2, 1 in the decreasing order. Followed by the name of the parent alkane is with respect to whatever number is the last number. So if it is 9, it's nonane, and that's the nomenclature. Is this clear?
Yes.
Now I'll give you one example. Now look at this structure. If you look at this structure, it is basically like this. Half opening of the book like. This is one cyclic ring, this is second cyclic ring, joined by two carbons common. Okay? First visualize kar do. This is how you can visualize. Then between the two carbon you have a bridge with two methyls on that bridge carbon. Okay? And there are two substituents. One is a ketone or a functional group, and other is a methyl which is bonded here. So this is methyl. These two are joined with the carbon having two methyl, and just adjacent to that you have a ketone. Understood? Okay? So it's a bicyclo compound because it's having two carbon common between the cyclic ring. Okay? Now this structure which I have drawn is basically the structure of Kapoor. That's camphor. Kapoor jo use करते हैं ना, that is this compound, a bicyclo compound. It's actually called a terpenoid compound. We will learn this later. But the family of these compounds are called terpenoids. So it's an example of a terpenoid. That much you can remember. Now the numbering. Most important part is numbering. First look at the two rings. Are they of different size? No. So bigger ring, smaller ring का concept apply नहीं होता है. अब functional group के priority पे आ जाता है. तो numbering has to be started from the bridge carbon, either this or this. Now I will start from this carbon because the ketone should get the lowest possible number. Bas. So I'll start with number 1 here, then 2, then 3, then 4, 5, 6. And then the bridge carbon which will always be numbered last. Bridge carbon का हमेशा numbering last में आएगा. How many substituents do you see now?
1, 2, 3, 4.
It's 1, 2, 3. Ketone is a functional group. So it will be 1, 7, 7 trimethyl. Then write bicyclo. The number of carbons of the bigger ring, but bigger कोई है ही नहीं, basically equal numbers आएगा. कितना? 2, 2 and the bridge carbon is 1. 2 to 1. Then whatever is the total number, that will be the parent alkane. So it will be heptane, and because of the ketone it will be on with the position 2. That's camphor का IUPAC name with respect to bicyclo nomenclature. Is this clear? Last example given. Now which would be selected as the bridge carbons?
The intermediate.
See, the carbons which are joining is this and this. So obviously these are the bridge carbons. Now here the number of carbon in the ring is 1. Here between them is 1 and here between them is 2. Now your doubt जो आपने पूछा कौन सा bridge select होगा. So if you look at this, then when you number, you are giving the number in the order bigger ring, smaller ring and last bridge. So here there is one carbon, here there is one carbon, but now there are two substituents, no substituent. So which should be the bridge carbon?
No substituent.
No substituent, because वो last में आ रहा है ना, तो इसका numbering पहले आना चाहिए. तो you can easily select the bridge. Understood? Yeah. So now the numbering starts from the bridge carbon, so it will start from either this or this. You have to move in which direction now?
Clockwise.
Clockwise of the bigger ring, because there is a substituent of methyl. So it is 1, 2, 3, 4, 5, 6 and 7. Once you do the numbering, nothing is different. So it's 2,
Methyl.
6, 6 trimethyl, bicyclo,
Bicyclo.
3, 1, 1. Bicyclo 3, 1, 1. And the parent of heptane. Look at the name. 2,6,6 trimethyl bicyclo 3,1,1 heptane.